Okay, so for a quick warm-up before we get into our notes and the explanation of what I want you to do with your quizzes, I want to take about 2 minutes and have you take these 4 right here and write them in interval notation. So if we were going to write these in interval notation, A would be the interval from 8 to 10, where 8 has a parentheses because we're not included. 10 has a bracket because it is included. All real numbers is the interval from negative infinity to positive infinity. X is less than negative 2 means we begin at negative 2 and we need to go to the left, less than negative 2. So we have the interval negative infinity to negative 2. Once again, parentheses because it's not included. And then X is greater than or equal to 17 would be the interval from 17 to infinity, where 17 has a bracket because it is included. Okay? I want to talk a little bit about your quizzes. First of all, those of you who were not here on Friday and have a blank copy of the quiz, you are taking it home and you are doing it like a homework assignment, but you do not get the opportunity to correct any mistakes. So just like everyone else, your quiz is due on Wednesday, but you're just going to complete it like a homework assignment and turn it in on Wednesday. Those of you who were here on Friday and got your quiz back, let me first remind you that this is usually one of the lower quizzes of the year. We're just getting back into the swing of things, especially for you guys. You haven't had formal in-person school for 5 months, so we're in a little bit of an adjustment period. So don't be freaked out by your score. I expected these to be on the lower end of what you'll usually be able to do here moving forward. Okay, so my expectations are higher for you on our next quizzes, and you will feel more prepared for the next quizzes also. But just keep that in mind. Like, don't panic if you didn't get as high of a score as you would have liked. Number one, you're going to correct your mistakes. And number two, this is usually one of the lower quizzes on a class average that I grade. Okay? That doesn't mean it's going to be the lowest quiz for everybody. I'm just saying on average. A couple things that I want to remind you about. When we are doing function notation, okay? First of all, when you had a problem like this, there was some of you that I wrote, keep going. There are 2 things that you have to plug in. First, you must plug in 2 to function f, and you're actually going to get a number. With that number, you are then going to plug it into function f again. So you're actually plugging in twice. Okay. Something else I wanted to remind you about, if we are subtracting a function, so let's say, and I don't have the quiz in front of me right now, I know it's part C, so I don't know if it was f of x plus 3 minus f of x. And I can't remember if that was the right function notation right there or not. But what I'm worried about is this right here. When you are subtracting a function, you need to subtract it in its entirety. You need to subtract all of the terms of that function, okay? So be careful with that. Now, on your quiz evaluation sheet, that yellow sheet that you got, you only need to fill out the questions you would like points back on. And it's not just, hey, I am going to redo the problem and I get points back. What you need to do is you need to tell me what kind of error it was. So on that left column, you're going to circle one of those 4 words. What kind of error was it? And I have the explanation of those errors up on my front wall above the board. Then you're going to redo the problem in its entirety, not just where you messed up. You're going to redo the entire problem. And then in the next column, you're going to tell me what your mistake was. For example, maybe on this one, you did not subtract f of x in its entirety. Maybe you did not carry that subtraction through f of x. That is a mistake that you could explain that you made. On those problems where there was multiple parts like A, B, and C, if you only missed points on B, you would only need to redo B, but you would need to redo B in its entirety, okay? You have until Wednesday to turn these in, so you have 2 days to correct your mistakes, maybe ask some questions about what your mistakes were, okay? If you have any questions or clarifications about that process, please email me, okay? All right, so let's get into our notes for 1.5. We are going to talk about 1.5 both today and tomorrow, and some of these things are going to be reminders like domain and range and increasing and decreasing intervals, but we need to be able to do these things with interval notation, okay? There's also a couple of things that I want to remind you about as we go through our lesson today. So, like I said, should be a lot of reminders. Most of the new stuff is just how to use our interval notation. So let's just remind ourselves about domain and range. We like to describe domain as our input and range as our output. Okay, so typically we're talking about domain are x values, y would be the range. Okay, so when we're looking at a graph like this one right here, okay, notice how we begin here at the coordinate 1, 1, and then we have a curve until this open coordinate right here at 5, 2. Okay. So if we were to describe the domain of this function, it begins at an x coordinate of -1, and we have x's all the way until this open coordinate at 5. And since it's an open coordinate, we would go ahead and put that parentheses there. Okay. In terms of the range, we need to look at where we have y values. So here it looks like our y values begin at -3 all the way until up here our y values stop at a +3. Both of those are closed circles, so we can put brackets because we need to include those values. Okay, so what I'm going to do is I'm going to put this problem up here for you to look at. And what I would like you to determine is what you think the domain is and what you think the range is. What I'll have you do is just turn to a neighbor and discuss what you think the domain and range is and how you would write it. Let's also go ahead and assume that these are arrows, okay? So what it looks like is we have x values all the way up until -1. We have a gap right here. And then we have x values again after x equals 1. So we would write our domain from -infinity to -1, and then we would union that with this next interval, 1 to infinity. We have x values here and here. Okay. Then it looks like our graph begins on the x-axis and only goes up. So we would describe our range as 0 to infinity, where we would put a bracket on 0 because we would include the value y equals 0. Okay. Let's remember how we determine a function. I know that this is something we spoke about a little bit the other day with our 1.4 packet. Remember, a function means one input for every output, okay? Which means graphically, we are going to use the vertical line test to determine if we have a function. So here, in example number 1, the vertical line goes through this graph 2 times. So this would not be a function, okay? Because our vertical line goes through more than once. But here in example 2 and example 3, our vertical line goes through the graph at most one time, and so these would pass the vertical line test, and this would be a function. Okay. What I want you to think about for a moment is, what does it mean to find zeros? So what I'll maybe have you do is turn to your neighbor again and just have a quick discussion. What does it mean to find zeros? What are we finding? Okay, so if I ask you to find the zeros of a function, I'm talking about these right here. Zeros are the same thing as x-intercepts. Okay, we call them zeros because the y value at each of those coordinates would be 0. Okay, so if I ask you to find the zeros of this function right here, then in order to do that, we are going to set the function equal to 0. So go ahead and write down this function, f of x equals 3x squared plus 22x minus 16. And what we need to do is we need to set it equal to 0. Okay. Now I know we've done a little bit of this already, okay? But what I wanted to go through is just a reminder of how to factor these trinomials, okay? The best way I would suggest to factor trinomials would be to do it by guess and check, all right? So we know that we need a 3x squared here for our first term. So 3x times x, we know is going to give us that 3x squared. Okay? Now, negative 16. What are different numbers that multiply to negative 16? We know that 8 times 2 is 16. So if we say plus 8 and minus 2, we know that negative 2 times 8 would multiply to negative 16. Okay? What we need to check for then is, what about our outside and our inside? So 3x times 8 would be a positive 24x, and a negative 2 times x would be a negative 2x. When we add those together, we would get our 22x. Okay, so now that we have our trinomial factored, we can set each factor equal to 0. So 3x minus 2 equals 0, and x plus 8 equals 0. So we can add the 2 over, divide by 3. There's 1 0, and then another 0 would be this negative 8. Okay. The last thing I want to talk about today in terms of new material would be this concept of increasing and decreasing. So what we're going to do is we're going to determine intervals of increasing and intervals of decreasing. So I want you to look at this graph, and I want you to think about, what are you looking for when you're looking for increasing? And what are you looking for when you're looking for decreasing? What of this graph will you try to take note of in order to determine which parts are increasing and which parts are decreasing? Okay. So when you look at a graph, we always need to read it from left to right, just like we read normal words, right? And anytime I ask you for intervals of increasing or decreasing, I'm asking you for the pieces of the domain, okay? So as we go from left to right with our x values, we need to look for y values that get bigger to determine increasing intervals, like this guy right here. As we go from left to right, our y values get bigger. Same with over here. And then for decreasing, from left to right, we need to look for y values getting smaller, like in this chunk right here. Okay. So this is the graph that we're going to use, and let's go ahead and assume that it goes forever in both directions, so I'm going to add those in right there. Okay. We are going to determine our intervals of increasing and decreasing. Okay. So this right here, we're just going to start from left to right. This first part, up until this coordinate right here, it looks like our y values are falling. So from negative infinity until negative 3, we're decreasing. Then, at this negative 3, we begin to increase until we hit this point right here. So from negative 3 to 0, we are increasing. Remember, we're using our x values, okay? Now, when we hit that top point at x equals 0, we start to decrease again. So I'm going to union because I have another interval to write. From 0 to, it looks like this coordinate has an x value of 3. We are decreasing again. And then at 3, we continue, or we change directions to increase. So from 3 to infinity, it looks like we are increasing. Okay. I will tell you that when you have increasing and decreasing intervals, you are always going to have open parentheses, because at these moments where we change directions, we call those our relative minimums and maximums. You're not increasing or decreasing. Okay. Okay. Now, what I want to talk to you, I have a couple things I want to talk to you about. So first of all, you have your first book assignment. So what I'd like to do is I'd like to go into my Google Classroom and show you a couple things. Okay. So if you go to classwork, first of all, at the very top of Chapter 1, you see Chapter 1 PDF textbook, okay, right here. And if you open that up, that is the entire PDF of our Chapter 1 of our book, okay? So you can look for pages there. Now, in order to check your answers, I have right here what's called Calc Chat. So if I press this, it's a website, and it has answers and their solutions. So if we go here, okay, it's already loaded. So Chapter 1, we are in Section 5, and I don't know what I assigned you, but let's say it's number 17, okay? Well, number 17, there's the work and the answer. For number 19, there's the work and the answer. Okay, so on any odd problem, you can not only check your answer, but you can also look at the work compared to yours. Okay, so that's really nice, and I really want you to utilize that. So both of those things can be found in your Google Classroom. So Calc Chat is up there at the class resources, and then the PDF of the textbook is the first thing under Chapter 1. Okay, now I do want to go ahead and talk to you about the green piece of paper that is being handed out. So you have your book assignment for tonight, which is very short. Check your answers. You have your quiz corrections, which are due on Wednesday. This green piece of paper is something for you to fill out over the next 4 days. So on Thursday, we're going to talk about functions and their transformations. And in order to do that, I need you to have in your head 8 basic functions. Now, there is one on there that you don't know yet. That is the greatest integer function, and we'll talk about that on Wednesday. But all of the other ones, you should have an idea of what they look like. So I'd like you to graph the parent function, talk about the domain and range. I will put an answer key on my Google Classroom on Thursday morning, so you can make sure that you have the right parent functions. But this is something that between now and Thursday, you need to be working on.